So in this video, we're going to see problems from exercise 9.3, which belongs to chapter number 9, areas of parallelograms and triangles. Okay, so we're going to see exercise 9.3. So the first problem is, we are going to see this problem number 1. Now let's read what the problem says. In figure 9.23, okay, this is the figure. E is any point on median AD. So let me use a highlighter. E is any point on this median AD. So AD, so this is A and this is D. AD is the median and E is any random point on this median, okay, of a triangle ABC. Okay, show that area of ABE, so ABE, again let's use highlighter. So this area ABE, okay, is equal to area of ACE. So ACE is ACE. We have to show, yes, basically we have to show area of this triangle is equal to area of this triangle. Okay, and the piece of information given to us is AD is a median. That's it. That is the only piece of information. So now let's get rid of all these things. Okay, so this is important information we have. Let me use a highlighter, that AD is a median. Okay, that's an important piece of information. So for the, we all know what is the definition of a median. A median is a line which connects a vertex to the midpoint of opposite side. Okay, so if AD is a median, then D is the midpoint of the side BC. Okay, that's very important point, or that's a very important conclusion. I'm just going to note it down here. So let's start from here. So given, okay, given AD is a median, AD is a median, therefore point D, okay, therefore point D is midpoint. Point D is a midpoint of the side BC. This is an important observation. So if point D is a midpoint, if point D is a midpoint of side BC, then BD is equal to DC. Okay, very obvious that BD will be equal to DC. And I'm going to therefore write, therefore BD is equal to DC because D is the midpoint. So let's mark it as 1. Now, then we'll go to point number 2. Now, let's remove this. Let's remove this. So now let's focus on, okay, this triangle. I'm going to again highlight it. Let's focus on triangle ABD. Okay, this triangle ABD and another bigger triangle ACD. Okay, these two triangles. Let's focus on these triangles. Now, if you look at these two triangles, these are the triangles with the same base. Okay, BD is the base for ABD and DC is the base for ADC. In fact, let's make a note of it. For triangle ABD, okay, BD is a base. BD is the base. And for triangle ADC, okay, ADC, DC is the base. Okay, and we all know that these two bases are equal to each other. Okay, from this equation number 1, BD is equal to DC. Now, if the bases of triangles are equal and if they lie between two parallel lines, then the area of triangle is equal. This is an important theorem, which in fact I have noted down here again. So let's remove this so that we can revisit it. Okay, so yeah, okay, so let's read out this theorem. Two triangles on the same base or equal bases. Okay, so these are my two triangles which are on the equal bases and between the same parallels are equal in area. Now, we don't have two parallel lines in this figure, but we can always construct a parallel line. How are we going to do it? Okay, assume that there exists a parallel line that passes through point A. Okay, so this is the parallel line which passes through point A and it is parallel to BC. Okay, that's an additional construction that we will do. So let's come here. Okay, and now I'm going to write here point number 3. Point number 3, construct a line, okay, parallel to side BC, parallel to side BC and passing through point A, passing through point A. Okay, so we have done this construction. Now let's zoom in. So we have this line passing through point A, it's parallel to side BC and this triangle ABD and this triangle ACD, these are the two triangles which lie between two parallel lines, okay, and they have the same basis, okay. So using this theorem, we can say that their areas are equal. So again, let's zoom in and make a note of that point. And therefore, I'm just going to write here point number 4. So area of triangle ABD is equal to area of triangle ADC. Okay, this highlighted one, ABD is equal to ADC. Now, this is again an important conclusion, and we are going to need it in the future. So I'm going to just mark it 2. Now, once again, let's come to this diagram here, and what we are going to do is we are going to erase. Yes, we are going to erase these things, the highlighted one. Okay, and I'm going to make some space to make note of new points. So okay, now let's zoom in a bit again. Now the first thing we proved is this triangle ABD has equal area to triangle ADC. Okay, now let us focus on another two set of triangles, and I'm going to highlight it. This time we're going to focus on EBD, a small triangle, and we're going to focus on ECD, another small triangle. Now even for these two triangles, if you notice, the pattern is exactly the same. The pattern is that these two triangles, they have equal bases, okay, BD is equal to DC, and they lie between the same parallel line. Which same parallel line? All I have to do is I have to take this parallel line and bring it down here, okay, or let's construct another parallel line, that will be easier. Basically another parallel line which passes through point E, so something like this, and which is once again parallel to BC. So that is my first thing I'm going to do. I'm going to do a construction here. So point number 1, construct a parallel line to, okay, construct a parallel line to side BC and passing, okay, and passing through point E, okay. So that important construction is done. Now our actual theorem or our actual discussion starts. Now for, once again, for triangle EBD and triangle EDC, okay, what do we have? Base BD is equal to base DC, okay. Why these bases are equal? Because D is the midpoint. And why D is the midpoint? Because given AD is a median. So we already had this discussion, BD is equal to DC. So once again we are going to use this theorem which says, let's try to zoom in. Yeah, once again we are going to use this theorem. Two triangles on the same base or equal base. So these are my two triangles, highlighted ones, which are on the equal bases, and between the same parallels, so between this BC and this line, between the same parallels, are equal in area. So once again using this theorem, okay, yeah. So point number 3. Thus we can say area of triangle EBD is equal to area of triangle EDC. Okay. Once again, this is an important conclusion, so I'm going to make it as point number 3. Now let's focus on this conclusion of point number 2 and this conclusion of point number 3. This triangle area is equal to this triangle area, and this bigger triangle ABD is also equal to this bigger triangle ADC. Now if I subtract from this area ABD the area of EBD, okay, so let me use a highlighter so it's easy to understand, and I think we'll get rid of this parallel lines as well. Okay, so what we are going to do is we are going to, let's try to zoom in, okay, from this area ABD, from this triangle ABD, I am going to subtract the area of this triangle. Okay, then what will I get? I'll get the area of this triangle. Okay, similarly, from this bigger triangle, okay, we are going to again subtract the area of this triangle, this small triangle. What am I going to get? I'm going to get the area of this triangle, and these two triangles are equal in area, and these highlighted green ones are also equal in area. So area of ABE will be equal to area of AEC, which is exactly what we have to prove. That area of ABE, this ABE, is equal to area of ACE. Okay, so yeah, so let's make a note of that point. And once again, in order to make a note of that point, I'm going to just okay the just overlap this so that we can note down these points. Okay, so let's once again try to zoom in, and I'll get rid of this again so that we understand what's going on. Okay, so point number one is going to be this. Point number one, area of ABD. So I'm going to highlight as I'm going to write it. So area of this triangle ABD. Okay, what is that made up of? It is made up of two triangles. Area of triangle ABE, okay, plus area of triangle EBD. Okay, so this triangle area ABD is made up of this triangle and this triangle. Similarly, I'm going to quickly write it. Area of triangle ADC is equal to area of triangle AEC plus area of triangle EDC. Yes, EDC. Okay. So, however, we just saw that area of ABD is equal to area of ADC. Okay, and area of ABE is equal to area of AEC. Oh, I'm so sorry. Not this one. Area of EBD is equal to area of EDC. Okay, these two values are equal. So, it is very obvious that area of ABE should be equal to area of AEC because it's a subtraction of the equal values. Okay, so just for the sake of understanding, if we say, okay, if you want to understand it in a better way, let's say the area of this triangle is equal to X, and let's say the area of this triangle is equal to Y. Okay, so this will also be X, and the area of this triangle will also be equal to Y, and then let's come a bit to this side. Okay, let's try to draw a line here. Okay, another way to understand it. So therefore area of triangle ABE, okay, area of triangle ABE will be equal to what? It will be equal to X minus Y, and here area of triangle AEC will also be equal to X minus Y. Okay, so as you can see, area of AB is X minus Y, area of AEC is also X minus Y. That means the area of two triangles are equal. So thus we have proved using this theorem that this is what we wanted to show. Show that area of ABE is equal to area of ACE. This completes the proof.